Next, we will discuss about JVM architecture. So, in this chapter, we will learn the internals of JVM. What are the different components we have in JVM? We will discuss about all those and how our class is loading into JVM and how our class will be executed, how it will create objects for us. Everything we are going to see in this JVM architecture. So, I want to show you how our class is executed inside JVM. What is happening whenever we create class and we execute class? What is happening internally? I want to show you. That's the reason I am explaining this topic to you. So it's nothing like I am wasting your time. I am explaining to you this JVM architecture because my students, whoever learning my course, I want my student to know all the topics without any missing points. That's the reason I am explaining all the topics very clearly. And I am also explaining JVM architecture, how class and programs internally how it is executed inside JVM. I want to explain to you. So first we will make a note about this. JVM architecture. This topic will let you know how our class is executed inside JVM and what are the internal components we have inside JVM, how our class is executing and how memory allocation will be allocated for our objects and classes we will see now. First, we will learn what is JVM. JVM is nothing but a Java virtual machine. I will explain you from very basic level. No need to worry. First, I will make a note about this. In this chapter, you will learn the internals of JVM and different components of JVM, and we will see what are the class loaders we have in JVM, class loader subsystem. And we will see classes loading mechanism, how our class is loaded inside JVM we will see, and we will see runtime areas of JVM. And execution engine and JNI, Java naming interface. And we will see different activities performed inside JVM when class is loaded and object created. comma, we will see memory distribution for all 4 types of variables, comma, methods, execution, procedure, comma, etc. So this is about what we will learn in this JVM architecture. We will learn the internals of JVM and the different components we have in JVM, and we will learn class loader subsystem. What are the class loaders we have? And we will learn classes loading mechanism, how class will be loaded, and we will see runtime areas of JVM, and we will see execution engine, and we will see JNI, and we will see different activities performed inside JVM when class is loaded and object created. We will see memory distribution for all 4 types of variables and method, static and non-static and local, and all those types of memory distributions we will see, and we will see execution procedure. Instead, if you gain some basic knowledge on what is happening inside JVM during our class execution, then this knowledge will help you understanding our Java program execution easily. That's the reason I'm explaining to you. It will help you when you write classes and when you create programs. It will help you, like, you will understand how our class is executed internally inside JVM. So what are the operations it will perform inside JVM. So by thinking about every student to understand easily, I want to explain this topic to you. This will also help you finding correct output of an unknown program. In some interviews, written test in addition to an enhancement of skill to develop high performance applications. So what is how you will understand JVM architecture? It is not any big process. I will explain to you easily. You can understand very easily. So knowing about JVM internals is nothing but like knowing about a human anatomy in deep. Like for example, a human body will have hands, mouth, throat, stomach and blood, and some other internal parts which are helping the digestive system to perform properly to generate energy from the food we eat. And of course, here we no need to know about complete functionality of these parts as we are not doctors. Yes, and also not going to do any surgeries, right? But by just knowing outer functionality, we can take complete care in getting energy generated by eating proper food at proper time in a proper way to live more years healthy and happy. So by knowing body part functionality, we can perform first aid to save life. Like, so if you compare JVM with our body parts, food is nothing but a program you are giving to JVM. Just I'm explaining you in an easy way. Food is nothing but a program you are giving to JVM. Then JVM internal components. JVM internal components are nothing like but hand, mouth, throat, stomach. Those are JVM, like I'm telling you example. So JVM internal components will execute the given program and gives the output. Output is nothing but like whatever the human when he eat food. So after eating food, digestive system will digest the food and will give energy to our body. Same as that JVM internal components, like we have some internal components, we will discuss about that, will execute is nothing but if you eat food it will digest, means when JVM is executing our class, when it comes to JVM, execute means digesting. Then when JVM execute the given program and it gives the output, JVM internal components are nothing but like hand, mouth, throat, stomach. Like that we have internal components in our JVM. So as I said in first paragraph, in this chapter we only learn the essential parts of JVM and their functionality. So let us learn JVM architecture. Let's start with definition of JVM. I will explain you with a diagram. So just assume that this is a human body. Human body. So human body consists of some internal parts like we have hands, mouth, comma, stomach, comma, blood, comma, etc. We have some internal parts in our human body. So these internal parts, what will do in our body? Will help the digestive system to perform properly, to generate energy from the food we eat. So all this point we have discussed. What human body will be having? Human body will be having some internal parts like hands, mouth, stomach, blood, some etc. What all these internal parts will do? It will help the digestive system to perform properly to generate energy. All these internal parts will help digestive system to perform properly to generate energy. Whatever the food we are eating, after eating food, by using all these internal parts, it will help digestive system to perform properly to generate some energy. So we have energy, that's why we are living, right? After explaining this, I will explain you how JVM works as it is how human body works. I will explain to you. So we will see how JVM will execute our code, and I will show you how you can easily understand JVM architecture, what internally happens. This is just an example. We are not a doctors to learn about human body. I'm just giving you example how our JVM works internally. Now we will see internals of JVM by using this example. So I have a Java class. This is my Java class. Some example.java. And this is my JVM. So if you compare JVM with our body parts, here food is nothing but a program. If you compare with human body, food is nothing but a class for JVM. This class is a food for our JVM. And JVM internal components are nothing but like we have in human body, we have internal parts like hands, mouth, stomach, blood. Same as this, our JVM also have some internal components. Internal components. So in JVM also we have some internal components like hand, mouth, throat, whatever we have in human body. And all these internal components will execute, will help, will help, will execute is nothing but whatever in human body, it will help to digest food and to get energy. Here, execute is nothing but a digesting. Internal components will execute the given program. And after internal components will execute the given program, here if you see for human body, after internal parts is helping to digest the food and to why it is helping to digest the food to perform properly, to generate the energy. Internal parts is helping for digestive system to perform properly to generate the energy. Here internal components are helping to execute the given program to generate output. Here it is energy. If you see with human body, if you see with JVM, to generate output, to generate output. These internal components will help to execute the given program and to generate output. This is how our JVM works, as how our human body works. So let's start discussing about JVM. First we will see what is definition of JVM. First we will see what is the definition of JVM. Java Virtual Machine. Definition of Java Virtual Machine. So what is the definition of Java Virtual Machine? JVM. JVM stands for Java Virtual Machine. JVM is nothing but it is a process-based virtual machine. JVM is a Java platform which is responsible to run our Java bytecode by translating them into the current OS, whatever the operating system in which we are executing our Java class. JVM is responsible to run Java bytecode by translating them into that current operating system machine language, either it is Windows or Linux or Mac OS. JVM provides a runtime environment with an equally partitioned identical memory areas for executing Java bytecode in any OS. From computer memory, it will get some memory and it provides some runtime environment for JVM to execute our class's bytecode in any OS. So the main reason behind the invention of JVM is we have already discussed to achieve platform independency. Means JVM is invented for running Java compiled code, that is nothing but a bytecode in all available operating system irrespective of the operating system in which it is compiled. Either you compile in Windows operating system or Linux or Mac OS, that whatever the Java compiled code which is called bytecode, you can execute in any operating system, either it is Windows or Linux or Mac OS. That's the reason to achieve platform independency we have JVM. So for this purpose, Oracle Corporation, Oracle, previously Sun Microsystems, now Java is acquired by Oracle Corporation. They have developed separate JVMs for every OS, for every operating system like Windows, Linux and Mac OS for running Java compiled code by translating it into current operating system, whatever the operating system you are using, specific machine language. I will make a note about this. JVM stands for Java Virtual Machine. It is a process-based virtual machine. JVM is a Java platform. It is responsible to run Java bytecode by translating them into current operating systems of machine language. JVM provides a runtime environment with an equally partitioned identical memory areas for executing Java bytecode in any OS. Just now we have discussed this point. JVM stands for Java Virtual Machine. It is a process-based virtual machine. JVM is a platform, Java platform. It is responsible to run our Java bytecode by translating them into current OS, machine language, and JVM provides runtime environment with an equally partitioned identical memory areas for executing Java bytecode in any OS. JVM provides a runtime environment with an equally partitioned identical memory areas for executing Java bytecode in any OS. So that means in this line what you understood, JVM provides runtime environment with an equally partitioned. It is saying that JVM is providing some runtime environment. It is partitioned some memory from our computer OS. Whatever it is, Windows or Linux or Mac OS, it is partitioned some identical memory area for JVM to execute our classes in runtime environment. This is my OS memory, my computer memory. This is my OS or computer memory. In this, JVM provides a runtime environment with an equally partitioned identical memory areas for executing Java bytecode in any OS. In this OS memory or computer memory, we have separate identical memory area for our JVM. We have separate identical memory area for executing Java bytecode in any OS. JVM provides a runtime environment inside OS memory with identical memory area inside OS memory for executing our Java classes bytecode in any operating system. So you have understood what I am saying. In OS, it will be having some memory as a runtime environment to execute our Java classes in computer. The main reason behind the invention of JVM is to achieve platform independency. Means JVM is invented for running Java compiled code that is nothing but a bytecode in all available operating systems or computers. Irrespective of the operating system in which it is compiled. For this purpose, Oracle Corporation previously Sun Microsystems developed separate JVM for every operating system for running Java compiled code by translating it into current operating system specific machine language. So this is point we have discussed just now. The main reason behind the invention of JVM is to achieve platform independency. Means JVM is invented for running Java compiled code, that is nothing but a bytecode, in all available OS. OS is nothing but computers, operating systems, irrespective of the OS in which it is compiled. For example, I have compiled my Java class in my Windows operating system and I want to execute that compiled class, which is nothing but a bytecode. I want to execute in Linux operating system. So it is possible in Java. For this purpose, Oracle Corporation and previously Sun Microsystems, our Java is acquired by Oracle Corporations. Before Java is invented by Sun Microsystems, they developed separate JVM for every operating system for running Java compiled code by translating it into current operating system specific machine language. So next we will discuss about what is difference between a virtual and virtual machine. Virtual and virtual machine. I want to explain you what is virtual and virtual machine. The concept called virtual machine is not newly invented for Java. The VM concept, VM is nothing but a virtual machine concept, is already existed in operating system and other languages. So first let's get some idea on the word virtual and virtual machine, and then we will learn more about our Java VM, nothing but JVM, Java Virtual Machine. So what is virtual? Virtual is nothing but, for example, whatever you are seeing physically in real world, this real world, for example, whatever you are seeing in real world is called a physical, and you and your friends in this world, real world, are physical. And what is virtual? Your dream world, whatever the dreams you are getting, all those dreams are virtual. Those dreams are not physical, and you and your friends in dream world are virtual. They are not real, means they are not physical, they are virtual, they are in your dreams. And we will see one more example. In this COVID pandemic, you are learning in online classes. Before you used to go for classroom training. So classroom training, you are going to class and you are learning some subject, that is called a physical. And you are sitting in your home and you are learning something which is online. The process which you are learning in online is called a virtual. Means you are sitting in your home, you are watching online classes from your computer. That is called a virtual process. Real world is different and virtual world is different. Real world is physical and dream world is virtual. You are going to classroom to learn subject, that is a physical, and you are learning something subject from online classes from laptop and sitting in your home, that is a virtual. So now you got some idea on what is physical appearance and what is virtual appearance. The meaning of virtual is not physical. It is a logical representation of one physical thing. So just now we have discussed the meaning of virtual is not physical. Means you are learning in online classes, but you are not going to classroom. It is a logical representation of one physical thing. By sitting in your home, your lecturer is teaching classes from your online classes. That is a virtual. So when it comes to programming in computer world, the meaning of virtual is a logical representation of a physical thing created in a computer through software. For example, we will see in real world your family is a physical, but a photo album in a computer. In your computer you have a photo album, that is called a virtual family. In a bike racing game, the bike is a virtual bike, that is not a real bike, that is a virtual bike. And in a temple run game, the person running and jumping is a virtual human being, he is not real human being, he is a virtual human being. These are the examples. I want to let you know what is virtual and real world. That's the reason I'm taking all these examples. So in all these examples, like the bike and the person are created virtually by using software. In a bike racing game, the bike. In a temple run game, the person running and jumping are created virtually by using software in a computer. They are not physically existed inside a computer. So you got my point, right? First I will make a note about this. The concept called virtual machine is not newly invented for Java. The VM concept is already existed in operating system and other languages. So let us get some idea on the word virtual and virtual machine, and then we will learn more about JVM, Java Virtual Machine. So this point I have discussed with you. Next we have discussed what is virtual. If I make a note about all these points, then you will remember, you will not forget all these points. That's the reason I am writing in my paintbrush. This real world is physical. You and your friends in this real world are physical because they are physically available. and your dreams, your dream world is virtual because it not physically appeared. You and your friends in dream world are virtual. So the meaning of virtual is not physical. It is logical representation of one physical thing. All these points we have discussed. Just I am making a note about all this. So we have seen some example what is physical and what is virtual. I will make about all those. In computer world, the meaning of virtual is a logical representation of a physical thing created in a computer through a software. So we have seen some examples. I will make a note about this. For example, what are the examples we have seen? We have seen in a bike racing game, the bike is a virtual bike. It is not a physical bike. It's a virtual bike which is created by a software in a computer. And in a temple run game, the person running and jumping is a virtual human being. In a temple run game, the person running and jumping is a virtual human being. He is not a physical human being. He is a virtual human being which is created by a software inside a computer. In above examples, bike and person in temple run are created virtually using software in computer. They are not physically existed inside computer. So all these points we have discussed. Now we will discuss about virtual machine. What is virtual machine and how virtual machine works we will see now. Virtual machine. What is virtual machine? A virtual machine is a software implementation of a computer machine. It creates an isolated duplication of a real world, of real computer, and allows us to perform operations as we perform operations in a real computer. First I will make a note about this, then I will explain you about virtual machine. A virtual machine is a software implementation of a computer machine. It creates an isolated duplication of real computer and allows us to perform operations as we perform operations on in a real computer. This is about virtual machine. A virtual machine is a software implementation of a computer machine. It creates an isolated duplication of a real computer and allows us to perform operations as we perform operations in a real computer. We will see with diagram how virtual machine will work and how non-virtual machine will work in our computer. So I have non-virtualized computer. And I have virtualized computer. We will see what is difference between non-virtual computer and virtual computer. So nowadays all the computers, all the operating systems are following virtual machine software implementation. I have discussed with you here. A virtual machine is a software implementation of a computer machine. Means virtual machine is a software implementation which is implemented in computer machine. Nowadays, whatever the laptops and computers CPUs which are designed, all those computers CPUs laptops are designed based on virtual machine software implementation. Those are nothing but a virtualized computers. But in the before days, in the initial days of computers, all those computers are non-virtualized computers. So, what is the problem with non-virtualized computers? The problems with non-virtualized computers are, in one computer, we can install only one OS. You cannot, like in single computer, you cannot install from one OS to another OS. And in non-virtualized computer, we can run only current OS specific compiled code in a platform dependent way. And we cannot use hardware resources effectively in non-virtualized computer. But nowadays, all the computers, all the CPUs are virtualized computers. All the computers, all the laptops are using virtual machine software implementation. They are implementing virtual machine software implementation. How they are implementing, we will see now. First, I will show you non-virtualized computer. How in the initial days, in the 90s, in the 1980s, in the 1920s, how non-virtualized computer looks like, how they have implemented software implementation, we will see now. Non-virtualized computer will be having a hardware, and operating systems. Operating system, like we have drivers. We will be having some drivers in our computer. These are the apps. This is how non-virtualized computers will be in the before days. First whenever computer invented, they have used non-virtualized software pattern. This is how it looks like. So we have already seen what is the problem with this non-virtualized computers. In one computer, we can install only one OS. For example, in that computer you have installed like Windows operating system. You cannot install Linux or Ubuntu inside that OS. This is the main problem with non-virtualized computer. And we can run only current OS specific compiled code in a platform dependent way. This is also a problem with non-virtualized computer. For example, you have compiled some program in your non-virtualized computer. It will run in only that non-virtualized computer, means that operating system. Only it works in that operating system. It will not work in another operating system. And we cannot use hardware resources effectively in this non-virtualized computer. Then all the developers are working how to use virtual machine software implementation in computers, in laptop. It makes more efficiently working software implementation, which gives a good and fast performance. That's the reason virtual machine software implementation came into picture. They have implemented virtual machine in all the computers which are working in the latest generations, laptops and computers. So we will see how virtualized computer works. Virtualized computer will be having hardware. Next, instead of a single operating system, virtualized computers will be having virtual machine monitor. Virtual machine monitor. It's nothing but VMs. VM, virtual machine, and to monitor that we have a virtual machine monitor. And we also have drivers in your virtualized computers. Next, in virtualized computers, you can create virtual machines like this. For example, I am creating 3 VMs. These are my 3 virtual machines. I have created 3 virtual machines in virtualized computers. And these 3 virtual machines can have 3 apps. So this is how virtualized computer looks like. Same in non-virtualized computer. In virtualized computer we have hardwares. But in non-virtualized computer we have a single operating system. You cannot use another operating system in non-virtualized computer. But when it comes to virtualized computers, we have virtual machine monitor. This allows your computer to install one OS in another OS. And we can run any OS compiled program in current OS in a platform independent way. By using virtual machines, I have created 3 applications here in virtualized computers in a platform independent way. And you can use hardware resources effectively in virtualized computers. So we can also create, I have discussed with you, we can install one OS in another OS. So by using software implementation, you can create guest OS, guest operating systems. Like in Windows OS, you can use Linux, you can install Linux, and you can install Ubuntu. These are my 3 virtual machines which is running 3 apps with different compilation programs in platform independent way. And I am running 3 virtual machines in a virtualized computer in 3 guest OS. Means this is a Windows OS, this is a Linux OS, this is a Ubuntu OS. You can install one OS in another OS in a virtualized computers. Nowadays in your Windows OS you can install Ubuntu, you can install Linux. How it is working? Internally this process is going on. So first you have to learn all this to learn how JVM executes your code. That's the reason I am explaining you from very basic scratch level to understand all the concepts. So this is the difference between non-virtualized computer and virtualized computer. So whatever the points we have discussed, I will make a note about all those. If we perform operations directly in a computer, we will have below problems. As shown above diagram. As shown in above diagram, we have discussed. So what are those problems? In one computer, we can install only one OS. Next, we can run only current operating system specific compiled code in a platform dependent way. Next, we cannot use hardware resources effectively. So these are the problems if we use non-virtualized computers. But nowadays no one is using non-virtualized computers. Nowadays all the computers are virtualized computers. If we perform operations through virtual machine software, will have below benefits. We will see now. What are those? In a single computer, we can install one OS in another OS. And we can run any OS compiled program in current OS in a platform independent way. Next, we can use hardware resources effectively. These are the benefits in virtualized machine.